Good morning, students. I am Vikram Singh Rathod, Assistant Professor at Center for E-Governance. Today I am representing the unsupervised algorithms concept using the K-mean algorithm. That is the overview I am giving in our previous e-lecture, and today the practical approach is using for the K-mean algorithm is defined in our today's e-lecture. First of all, I am introduce the algorithm about the K-mean algorithm so you can understand. The K-mean clustering algorithm computes the centroids and iterates until will it find optimal centroids. At the centroids are the components those are used in using a database that is used in our practical implementation. We can use a database and that define the centroids in the K-mean algorithm. It assumes that the number of clusters are already known. It is also called the flat clustering algorithm. The number of cluster identifying from data by algorithm is represented by K or in K means. In this algorithm, the data points are assigned to a cluster in such a manner that the sum of the squared distance between the data points and centroids would be minimum. It is to be understood that less variation within the cluster will lead to more similar data points within same cluster. So I am defining the steps. Those are used in K algorithm, K-means algorithms. First of all, we can understand the working of K-mean clustering algorithm with the following steps. The steps are number 1 to 4. In the first step, first we need to specify the number of clusters K and need to generate by this algorithm. Our second step is randomly select K data points and assigning each data point to a cluster. In a simple words, classify the data based on the number of the data points. And the third step is it will compute the cluster centroids, and the fourth or last step is keep iterating and following until we find the optimal centroids, which is in the assignment of a data points to the cluster that are not changing anymore. So I am describing the fourth table as a subpoints. At 4.1, first the sum of squared distance between the data points and centroids would be computed, and the second step is we have to assign each data point to the cluster that is closer than other cluster. And the third one is at last compute the centroid for the cluster by taking the average of all data points of that cluster. The K-mean follow expectation maximization approach to solve the problem. The expectation step is used for assigning the data points to the closest number, and the maximization step is used to compute the centroid for each cluster. That is a basic approach is using K-means algorithm. While working with K-mean algorithm, we need to take care of the following things or steps. While working with clustering algorithm include K-means, it recommended to standardize the data because such algorithms use distance-based measurement to determine the similarity between the data points. So we can follow the standardized data set in this K-mean algorithm. Due to iterative nature of the K-mean and random initialization of the centroid, a mean may stick in a local optimum and may not converge to global optimum. That is why it is recommended to use different initialization of centroids. Implementation in Python using Anaconda spider tool. We write the following code of a k-mean algorithm and helps to understand the concept behind the k-mean using the datasets uh, from various libraries we can use in this code. So first of all, I am defining a first example for k-mean clustering. In this example, we understand how to k-mean work. We are going to first generate 2D dataset that contain 4 different blobs. It means the 4 areas, those are defined in a 2D plot diagram. And after that we'll apply k-means algorithm to see the result. First we will start by importing the necessary libraries. So first of all, we import the library matplotlib.pyplot as a PLT to create the graph or visualization of the data, so we can use matplotlib library. Then after I am creating or import a seaborn as a SNS set to create the centroids or importing the data sets of the centroids that is used in a k-mean algorithm in our program. Then after the calculation purpose, I need to import the NumPy library as a NP. Then after from sklearn.cluster import k-mean. It means the sklearn a library and the cluster is the dataset that is imported the k-means dataset items or fields, those are used in our program. The codes that is used to create the 2D container is 4 blobs, so that's why I am defining the code from sklearn.dataset.samples underscore generate import make blobs. So I am defining the variable x and comma y true is equal to make blob, and then defining the number of samples is equal to 400 and center is equal to 4 and clustered standard is equal to 0.60 and random state is equal to 0. It means the after executing the samples are defining number of samples are 400 and the center is divided the 4 part of the visualization of the data in a grid form, and each clustered is standard size is equal to 0.60 and the random state is 0. So after execution I am defining the comment here and that is used to visualize the data. So that's why I am call the PLT of the matplotlib and then the scatter method and the put the arguments such as x columns and the y columns, and also use the s as a 20 values as an argument, and then after plt dot show is method is used that is create the diagram. You can notice that there are 4 type of blobs are defining in this slides that is created from the cluster database of the k-mean methods. And then after I am also provide you a executional of the above code in a Anaconda environment using spider tool. You can also use this code and run the program or understood the concept behind it k-mean algorithm. Next we make the some number of clusters train and the model do the prediction as per the following. So we can use the prediction methods. So that's why I am create a variable k-mean is equal to k-means and put the value as n cluster is equal to 4 and the and k-mean dot fit and put the x variable, and then after as a y k-means is equal to k-means dot predict x. It predicts the values those are used in our program. Now with the help of following code we can plot and visualize the cluster center picked by k-mean estimator. So I'm call a library here from sklearn dataset sample underscore generator import make blobs, and then defining the variable x and y, and is equal to make blobs, and put the arguments such as samples and centers and cluster standards and random states. The following code is execute and visualize the data. Then so I write the code plt.scatter and put the arguments that's defining in our visualized data. After executing the code, then after plt scat.center, and then put the values from zeros and cluster colon 1 and c color is equal to blue, and state or number of the values are equal to 100 and alpha is equal to 0.9. And then after the last statement that is used to plot the diagram is plt.show, and after executing it, it creates the diagram that is defining the codes as per defining our code. You can show in this slide x-axis and y-axis as per the defining our code. The blobs are created, and you can notice that the blue points are defining the clothes or clustered as per the our defining in the code values. And then I'm also defining in the execution of the above code in using Anaconda environment. You can also use this code to execute the above k-mean algorithm and understood the concept behind it. And I'm giving a second example for the k-mean. In this example we are going to apply k-mean clustering on a simple digit dataset. K-mean will try to identify similar digit without using the original label information. First of all, we start by importing the necessary packages. As per the previous library, we can import the above libraries such as matplotlib and cburn and numpy and sklearn.cluster import k-mean. It means sklearn is a library and cluster is the part or that import the dataset of k-mean. Now load the digit dataset from sklearn and make an object of it. We can also find number of rows and columns in the dataset as following. So that's why I am writing here the code from sklearn.dataset import load digit. It import the data set as a load digit. So I am defining a variable digit is equal to load digit method. It means it's called from the sklearn dataset, or then after digit dot data dot save method is used, and our output is defining the number of values those are used in load digit database. So you can defining here out after executing, and there are 1797 comma and 67 are samples, and the features those are stored in our load digit dataset. We can perform the clustering as we did in example 1. So that's why k-mean is equal to k-mean n cluster is equal to 10, random state is equal to 0, cluster is equal to k-mean dot fit method predict the data, and then put the digit dot data for the prediction values, k-mean dot cluster underscore center dot shape. Then after execution our output is 10 comma 64, that is define the output. K-mean created 10 clusters and 64 features. Then after we can also visualize the above dataset using the matplotlib library. So I'm defining a fig variable and a ax variable is equal to plt dot subplot 2 comma 5 and figure size is equal to 8 comma 3, and then center is equal to kmin dot cluster underscore center dot reshape the values. So I am defining the states here, start step and stop values as a 10, 8 and 8, and then after I am defining the iteration methods to create the values. So that's why I am use a for loop, and in for loop I am defining axi variable and centered in zip and ax dot flat comma centers, and as per the syntax I am close the bracket and put the colon and defining the statements. Those are execute in the loop axi dot set x sticks and y sticks, and then after axi dot imso center comma interpolation is equal to nearest, and cmap is equal to plt dot cm dot binary. After executing the output you can show in the next slide as a image. You can learn easily k-mean method. So defining the values in a numbers you can see in this slide, and I am giving also a running code for your convenience to write the code and execute the code in a Python using Anaconda environment, using Spider tool or Jupyter tool as you can wish. The following line of the code will match the learned cluster label with the true label found in them from scipy.stats import mode. Here scipy is a library that import the statement stats for the statistical calculations and then import the mode. So that's why I am defining a variable label is equal to np.0 underscore like clusters, and I am defining a for loop I in the range 10, and mask is equal to cluster is equal to I, and label is equal to mask is equal to mode digit dot target mask 0. And next we can check the accuracy as follow from the from sklearn.metrics import accuracy underscore score accuracy underscore score, use the parameters digit dot target and labels, and then after execution it's defining the some values. Those are defining the predictions of the data set that is used in our program. So the above program so that the accuracy is around 80%. For your convenience I am also writing the displaying the code. You can also use this code and execute the code. And then last slide I am defining the applications those use k-mean clustering algorithms. So that's why I am defining the k-means algorithm use areas for executing the machine learning. So that's I am defining the cluster analysis as for the following applications. First of all, to get a meaningful intuition from the data we are working with, and the number second is cluster then predict where different models will be built for different subgroups. To fulfill the above mentioned goals, k-mean clustering is performing well enough. It can be used for following applications such as applications those are used to describe the k-mean algorithm and output as a user requirements. Those areas are marketing segmentation or called market segmentation, document clustering, image segmentation, image compression, customer segmentation, analyzing the trend on dynamic data. In the above examples, first of all, we use the database related to particular application. Thanks, students. Our official channel CG's APR is use various type of subjects e-lectures, so you can subscribe it and learn the important uh, areas of technologies such as computer science and electrical engineering, mechanical engineering, automobile engineering. Most of the lectures are provided for your learning. Thanks, students.